solving equations, and today what we're going to do is we're going to look through we're going to look through really describing what's going on along the way, so that we're absolutely clear. We took a few shortcuts yesterday as we were kind of looking at the difference between equations and expressions. Now what we're going to do is we're specifically going to show how to solve the equations using those inverse operations we talked about yesterday, and we're going to explain that in words as we go along. So actually explain what's going on, and that kind of should hopefully reinforce the idea of exactly what we're doing as we go along. So here's an example, first of all, right? An example of what we're expected to do. First of all, we've got our equation right here. Okay, 2x minus 7 equals 13. The first thing we're doing, and again, like we said yesterday, there are multiple ways of doing this, right? But there's a shorter way of doing it, and that's kind of what we're going to focus on. We're going to ignore things like, we looked yesterday at the idea of if we started with 2x minus 7 equals 13, that it is possible, of course, to divide both sides by 2 first. It's unusual and irregular, but we can do that. The problem with what happens when we do that is, of course, we end up with some fractions we've got to deal with to begin with, right? Okay, and that's equal to 13 over 2. Okay, then we still have to do this whole addition on both sides, right? Except now we've got to do it with fractions, and we've got a lot more things to remember. Okay, so it doesn't mean that it's not possible. It's just annoying, right? It gives us 10 over 2, which is equal to 5, right? So it gives us the same answer. Ooh, did I do something wrong there? I did do something. I said 10 instead of, you see? All right, 13 plus 7 is clearly 20, not 10, right? Okay, and that is equal to 10, right? Okay, so, the kind of the shorter way of doing this is really kind of, it helps you not make silly mistakes like that, okay? All right. So the idea here is what we're doing is we're actually doing what we're supposed to do first. We're going to work our way towards the variable rather than attacking the variable first. We're going to work our way from the outside in towards the variable, and we're going to describe what we're doing each time. So we're adding 7 to both sides here. Then we rewrote the equation. Another way of saying this is we combined like terms. But we rewrote the equation. Now we're left with 2x the 2x equals 20. So every time we're rewriting the equation. Okay. Then we divided both sides by 2, and our final answer is x equals 10. Right? So we rewrite. Essentially, we're rewriting the equation again. Every step, we're rewriting the equation. There's a few different ways of showing this. Another way of actually showing this, and I'm going to clear what I've got, this mess that I've got over there for a second. I could look at this in a different way. I could say 2x minus 7 equals 13. And in my first line here, I added 7 to both sides. I could say, well, I added 7 to both sides. And I rewrote the equation as 2x equals 20. Right? So you can do it in line like that. I divided both sides by 2, so again, I divided both sides by 2, and therefore now I'm rewriting the equation here again. Final answer is 10, and that was like that. So you can shorten up the way you're doing it. You don't need to add an extra line every time. You can do it in line, so to speak, right? But the key idea is if you're doing it in line, you really do need to be explaining what's going on each time, and the whole point of this lesson here is explaining what's going on every step of the way. So let's look at the next slide. All right. So here we have 3x minus 7. We're going to add 7 to both sides. I need to turn that on. Okay, we're going to add 7 to both sides. So I add 7 to both sides. And then I rewrite the equation. Right, that's what it said in the previous slide. That's what we're going to do. Right? We rewrite the equation. So negative 7 plus 7 is 0. So we got 3x equals 19. Right? And this here is kind of giving us a really good idea. Remember, keep that equal sign completely lined up all the way along. That equal sign is essential. That's kind of why we've got this line right through it to kind of remind us of that. Right? I divide by 3 on both sides. Right? Okay, it's going to be assumed that from now on, it's going to be assumed that it's always going to be on both sides, right? So I divide by 3 on both sides, and therefore I get x equals 19 over 3. I'm going to leave it as 19 over 3. It's not a pretty one there at all. Let's get rid of this silly thing that happens first thing in the morning every morning. It doesn't matter what I'm doing, it does it. Okay, and then I rewrite my equation. I rewrite my equation, or I rewrite the equation, noting there we've got x here. I'll rewrite the equation. Combine like terms is another way of saying this. I combine like terms. You might see that eventually, even though there's no like terms to combine. Essentially, what you are doing here is this -7 and the +7. You are combining those like terms. I'll show you that in the next one. So let's look at it as in a different way of writing this. Okay. So what I'm going to do here is I'm going to start writing inline. Okay. So in this case, I've got an 8 I need to get rid of. So I subtract 8 from both sides. Right. And what I'm going to do here is I'm going to put a -8 in here, subtracting 8. I've already got the negative here, so I don't need to put a plus in. No, be careful with that. And I'm going to subtract 8 here. Okay. If you've got space, put it in. I mean, even rewrite it as -4x plus 8 minus 8. And now I combine like terms. So combine like terms. So now you can see we're using appropriate vocabulary. Okay, so combining like terms, that -8 and the +8 cancel out because we're combining them, right? And we get -4x equals 12 minus 8. That's combining like terms again, and that's going to be 4. Right? So now we're going to divide both sides by 5. And once again, combine like terms. Oh, I don't know why I'm dividing by 5. That was silly of me. Let's divide instead by 4, which would be far more appropriate. Divide by 4. It's clearly too early on the snowy morning. And combine like terms. Right? I'm a big fan of shortening things up, as you can see. Combine like terms. I'm actually going to divide by -4. That's right, and that's going to work out. It's clearly too early this morning. 4 divided by -4 is -1. Okay. Again, we're combining like terms because we're actually dividing by the 4. We're actually combining those terms that are alike. Right, is part of all of this. Okay, and we're done. Okay, so that's kind of, we're getting closer to what the expectation is now at this point of what we're supposed to do along the way, right? So we're going to add 5 to both sides. Add 5, right? We're going to combine like terms. So combining like terms there gives us -5x equals, oh, look at that, -5 plus 5, that's equal to 0. We got to use the placeholder of 0 here because we have nothing else on that side. Okay, and then divide by -5. So we're going to divide by -5. Well, the 0 divided by -5 is still 0. And x equals 0. Right? Not like dividing by 0. Don't try that. And let's be clear. That's combining like terms again. Okay. Right. So we've got 2 more examples to look at here before I release you on the practice. Some larger numbers, no need to be afraid of those larger numbers. All we're doing is exactly the same thing. So we're going to subtract 32 from both sides. Notice I'm putting in the plus as well because that's a positive 98. And I'm going to subtract 32 from this side as well. So I got negative 32 and positive 32. So hang on, subtract 32, right? Now combine like terms, right? So combining like terms cancels out those 2. I get 98x equals, what's it, 196, I believe, because there's a difference of 4 between those 2, so I take the 4 down. Okay, there we go, 196, right? Which I know is 98 times 2, which is really nice, okay, which is, so I'm going to divide by 98, and that's going to give me a combined like terms again of x equals 2. Look at that. Okay, nice and tidy, right? Right. And finally, one last example here. Again, we're going to work our way towards the x. We're going to subtract 11 from both sides. Subtract 11 from both sides. Notice I'm keeping the sign in the front. Are we going to add? A better way of saying this is, like I was saying before, is you're not subtracting. You're adding. You're always adding. Always adding. But we're adding a negative 11, right? We've got a positive 11, so we're going to add a negative 11, right? Because it's the inverse operation. So let's write that, so that we understand that that's also right. So we're adding negative 11 to both sides, right? That's the same as subtracting. That means subtract 11, right? Same thing. Let's just be clear about what we're doing, because it does look like we're adding here, doesn't it? But we're actually adding a negative 11. Okay, and here it looks like we're subtracting, but we're actually adding a negative 11, all right? Just to be clear. All right, so what combined like terms right now? Combined like terms, cancel these 2 out, gives us a negative 7x equals 32 minus 11, that's 21. And this should work out nicely again, so divide by negative 7, right? So divide by negative 7, right? That reinforces the idea that the sign belongs with the coefficient, of the sign belongs with the term that follows it, right? And of course that cancels those out, and we get ourselves x equals negative 3, because 21 divided by negative 7 is 3. So combine like terms there again, or provide the answer. So hopefully that gives you a general idea. What we're looking for here in the worksheets as you're going through this is very clearly explaining what you're doing in every step, right? This is going to do 2 things. First of all, it's going to reinforce what you're doing. Second of all, when you turn that into me and I'm looking at it, I will be able to see clearly what kind of mistakes you're making. If you are making any mistakes, I'll be able to see clearly, and I will be able to put you right. So this is not something you will need to do all the time. This is something that just for this lesson we are doing to make sure that the process is properly learned. So go ahead and work on the practice on that. You got 2 practice worksheets for this. One of them, which I think specifically deals with division more than anything else. So go ahead. Good luck.